Calculators are great. I even saw my dad to buy one when I was younger. If I wanted to find the length of this line, I wouldn't be able to, because this isn't even a line. If it was, I could just type this into the calculator and... Wait, that's not right. Okay, there we go. But what if you don't have a calculator? Any normal person would just call 911 for help, but I've ingested too much battery acid to worry about that. This is a cosine table. These could be read to quickly determine the cosine of an angle without doing hours of awful approximations every time you made a measurement. But what if you wanted to find the length of this line? This is the versine table, since subtraction is not very fun. It's also used in the definition of the most important ancient trig function, but I'll get into that later. The problem with people is that they end up getting ideas. Let's back up a bit. This is a unit circle. Each point on it can be described with an angle as well as two-dimensional coordinates. Since each angle is only one point associated with it on the unit circle, but not the other way around, there exist two functions which map an angle to its corresponding dimensional components. These are the sine and cosine functions, whose values are equal to the length of their respective color-coded lines. From here we can derive the remaining 4, or 20, trigonometric functions, which map an angle, or more accurately the length of an arc on the unit circle, to some strange number. The first is the tangent, which isn't equal to the slope of the line tangent to the circle at that angle, because that's the negative of the cotangent. Next we have the secant, the reciprocal of the cosine, and the cosecant, which is the reciprocal of the sine. Yeah. At this point, you'd probably put down the textbook and put on the oil. Pause the video until you've done this. Here's another graph, which avoids the overlapping of the previous one. Take note of every line and function, because you better remember all of them. I already talked about the first sign, so I'll skip over it for now. Invented over 2,000 years later, the x-secant is used to survey railroad tracks or something. This is since it's the distance from one endpoint of an arc to the intersection of the two lines tangent to the other endpoint. Going back to ancient times, the chord of an arc is the ratio of the distance between each endpoint to the radius. Back in the day, chord-based trig was a lot better than the sine-based versions we have today, since the Cartesian coordinate system hadn't really been invented yet. Finally, the two-argument arctangent function shits out an angle based on a coordinate. Don't like this formula right here? This is the piecewise definition of the function, which I shamelessly stole from Wikipedia. Still don't like it? Here's an algebraic abomination derived by me. This concludes level 1. Past this point, none of the functions have any worthwhile properties, either because they become redundant after hundreds of years of improvement when it comes to approximating trig values, or I just made them up myself. The first of these is the x cosecant, which is redundant because, well, I should probably explain what a cofunction is first. In trigonometry, the cofunction of an angle is the function of the complementary angle. Take a right triangle with hypotenuse 1, for example. The sine of an angle t is equal to the length of the opposite side, but it is also equal to the length of the adjacent side of the complementary angle, hence the term cosine. For functions with such niche uses as the x-secant, there is no reason to use the cofunction instead of just the regular function shifted around a bit for something. All that being said, I have a video to make. The coversine is the cofunction of the versine, and the vercosine is shit. No prizes for what the covercosine is, I'm afraid. This swiftly ends level 2. Beyond this, we have to use the half-angle formulas, which is why the background for this section is hell. The Haversine is the square of the sine half-angle, the Havercosine is the square of the cosine half-angle, and the Hacoversine and Hacovercosine are useless. The antichord. This one's kind of neat if you want to incorporate the diameter in a trig for some reason. The cochord. The anti-cochord. That's enough of that. Well, okay, it's a disaster.